understanding scientific notation. What is the point of scientific notation? The point is to represent really small and really large numbers in sort of an abbreviated manner. So any number can be written in scientific notation by expressing it in two parts. A coefficient, A, and A has to be, now notice this notation here. 1 is less than or equal to A, which is less than 10. So A could be equal to 1, and anything up to, but not equaling 10. We can get really close, but it can't equal 10. And a power of 10, where the exponent has to be an integer. So what's an example of that? So 2.4 times 10 to the third power. 2.4 is a number somewhere between 1 and 10 on our number line, and 3 is an integer. 4.45 times 10 to the negative 2. 4.45 is, again, somewhere between 1 and 10 on the number line, and negative 2 is certainly an integer. So let's look and see about these examples to see if they're written correctly. And if not, we've got to state the reason. So it says 2.10 to the 0 power is the diameter of a horse chestnut. So let's examine it. Let's examine that coefficient, which is 2. 2 is a number between 1 and 10. That's okay. We're good with that. And then our exponent is 0. Is 0 an integer? Yes. Okay, so that one's correct. Neptune is about 4.488 times 10 to the 9th kilometers from the sun. That's a really big number because that's a really big distance. So is it written correctly? 4.488. That is a number somewhere. Our coefficient is between 1 and 10. So that's good. That gets a smiley face. And then is our exponent an integer? Is 9 an integer? Yes. So that one is correct. Number 3. We look at, there's our coefficient. It's 0.01. 1/100ths. Is that a number between 1 and 10 on the number lines? And that is a frowny face. That's no. That's a number less than 1. But let's keep going. Is -5 an integer? That's correct. That's true. But our coefficient, okay, so we're going to say that it's incorrect. Our coefficient, okay, is less than 1. What about the football field? 10 times 10 to the first yards long. So again, let's examine our coefficient. It's 10. It's equal to 10. Can our coefficient be equal to 10? Go back up here, and it says it cannot equal 10. Okay? But let's keep going till that gets a frowny face. Let's look at 1. Is 1 an integer? That's true. Okay, so it is incorrect because we have to fulfill both situations. So it's incorrect, again, because the coefficient I'm going to abbreviate the word coefficient. The coefficient is equal to 10, and we can't have that. So let's skip ahead. We're going to come back to 5 through 8. Let's go over here to write each number in standard form. So we've got scientific notation. Let's work backwards. okay, to standard form. So 7.1 times 10 to the third power means times 10 three times. So let's find out what that value is. So 10 times 10 is 100, and 100 times 10 is 1,000. So 7.1 times 1,000. Right? 7.1 times 1,000 should give 7,100. Okay? We're going to jump down to 11. 9 times 10 to the fourth. So we have 9 times 10 four times. So 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 9 times 10,000 should give you 90,000. So that's we just wrote both of those numbers in that were in scientific notation in standard form. So let's look over at number 10. So 8.12 times 10 to the negative 3. Well, you know to take the reciprocal when you have a negative exponent. If I take and I put this 8.12, okay, or 8 and 12 hundredths over 1 times 1 over what is 10 to the third power. Okay, by now you should know that that's 1,000. Okay, so now when we multiply across, we end up with 8.12 over 1,000. Now, when we do that division, okay, you should end up with 0.00812. Okay, that's a pretty small number. Okay, but we just wrote that in standard form. Now let's go back to, let's do number 12. So let's do the same thing. So 2.5 times, take the reciprocal because it's a negative exponent, and then think to yourself, okay, 2.5 times 1 over 100. Put that over 1, multiply, so 2.5 or 2 and 5/10 over 100. And when we do that division, okay, 2 and 5/10 divided by 100, we end up with 0.025. Okay, by all means, use your calculator, do that division. Okay, and let's hop back to the front page again, and let's look at 5 through 8 that we paused on for a moment. Okay, so now we've got to write each in scientific notation. So we have 427 and 7/10. Okay, so let's think about our place value. We're going to put that over to the side. Okay, that's our tenths. Okay, one place after the decimal. 0.01, that's our hundredths. Okay, should move that over. I'm running out of space a little bit there. Oops, I'll rewrite that. So 0.1, there's our tenths. There's our hundredths. Okay, that TH hundredths, THS. 0.001. There's our thousandths place. Okay. All right. So we know our coefficient has to be, okay, between 1 and all the way up to, but never equaling 10. So I need to move that decimal. So my coefficient is good. Times, now when I read that to start, I said 427. So that's multiplied by 100. So 4.277, our coefficient looks good, times, now 100, you know, is 10 squared. Okay, so 10 to the first is 10. 10 to the second, 100. 10 to the third, 1,000. All right, so now this next one, number 7, 8,562 and 1/10. So let's make that coefficient somewhere between 1 and all the way up to, but not equaling 10. So my coefficient looks good so far, times 10 to what power? Now when I initially read that, I said 8,562, 8,000 thousands. So our 1,000 is 10 to the third. Okay? So what about over here to the side, number 6? I'm going to see if I can get my stylus to move. Doesn't want to move. There we go. Let me change color. So how would I read that? So I've got my tenths, my hundredths, my thousandths spot. Okay? So I've got to make my coefficient somewhere between, 1 and all the way up to, but not including 10, not equaling 10. So I've got to say 7 times, now what's my power of 10? So my power of 10, okay, I said thousandths. Okay, so we've got to go with -3. Okay, or let me back that up. Okay, so I could say, let's use it as, so here's our coefficient, 7 times, okay, 1 over 10 to the third power, okay? And so because we said that was 7 thousandths, now let's take it one more step. 7 times, oops, a little technical difficulties, 10 to the -3, okay? Let's try number 8. Hopefully, if you didn't catch on to number 6, you'll catch on to number 8. So we've got 6 hundredths. There's my coefficient. Okay, remember it's got to be between 1 and all the way up to, but not equaling 10. Now we've got to have a power of 10. So right now, okay, that is 6 hundredths. So 6 hundredths. Okay, 1 divided by 10 to the second power. So 6 times, now we've got to flip that, times 10 to the -2. Okay? So those are our numbers written in scientific notation. So let's hop back over to the last two. It says, identify the greater number in each pair, justify your reasoning. So let's look at 5.6 times 10 to the second and 2.1 times 10 to the third. So this 5.6 means 5.6 times 10 2 times, and 2.1 times 10 3 times. So this is 5.6 times 100, okay? We've got 10 to the second, okay? And this 2.1, we've got times 100 times 1,000, okay? So we've got a greater power of 10, okay? So this one is our larger one, and what's our reasoning? Because we have a greater power of 10. Okay, now let's look at this next one, number 14. So 3.4 times, let's flip it, 1 over 10 to the first, okay? And that next one is 1.1 times, again, let's flip it, 10 to the first. Okay, so their power of 10s are the same, so that's not going to help us out in comparing. But now let's look at 3.4 and 1.1. Which one is greater, 3.4 or 1.1? If the powers of 10 are the same, that 3.4 is going to be larger, okay, because we have a greater coefficient, okay, with the same power of 10. okay? Nice job, guys.